Good morning, this is your stats sensei, Mr. Spensei, and this is the first scenario for the pre-quiz. No, I'm not. Yes, I am. Schizophrenia. In the US, it's estimated that about 2.8 million adults have schizophrenia, so that looks like our population size. The table in the bar chart below summarize the age of diagnosis in years for a random sample. So we have a single random sample of 207 men. That sounds like that's our population, our sample size. So our population is 2.8, our sample size is 207, that's N. And with 207 men and women currently being treated for schizophrenia. All right, so it looks like we have men and women here, and we have our different age groups here. Those are our two variables, and show the same thing in the table, or in the graph as well. Do the data provide convincing statistical evidence of an association? That's a key word. That lets us know it's a test of independence. If we didn't know already, looking at the table, we probably thought it was between gender and age group and the diagnosis of schizophrenia at alpha equal 0.05. Please remember, when we are talking about a test of independence, we're only caring about, we're not caring about the totals when we go to run this thing. So in this case, we have a 1, 2, and 1, 2, 3, 4, a 2 by 4 matrix. 2 rows, 1, 2, 1, 2, 3, 4 columns. All right, so let's take a look at this. The first thing, the hypothesis. Well, age group and gender are independent in the diagnosis of schizophrenia, which means they are not associated. All right, so that would be our first one. The next one, and remember, we always make the whole positive. So that is a positive statement. They are independent. The ha, age group and gender are not independent. That's a negative, and a ha is always a negative statement in the diagnosis of schizophrenia, which means they are associated. Okay? Please add the not associated and the associated to your work. All right. We need to go ahead and figure out what our expected values are. So here we go. Stat. Second matrix. So if for those of you who've missed this before, you're going to press the blue button up here a second, followed by the X -1. You're going to go over the word edit, and you're going to put in the matrix 2, enter, 4, enter, because we have 1, 2 rows. And as I said a moment ago, we do not consider the totals when we're entering the matrix. So 1, 2 rows and 1, 2, 3, 4 columns. And once we have all our data entered, should look something like that. Now, I want to point something out. We have a data size of an observed value of size 3. We can have observations of less than 5, but our expected values have to be greater than 5. So we need to make sure that all these expected values are greater than 5, but we're okay on the observations. All right, so the next thing, stat test. And while it seems a little bit weird, we're going to go ahead and run this test. So stat test. Go all the way over to letter C for chi-squared. This is not a goodness of fit. This is independence. GOF is for goodness of fit. So we're just doing a chi-squared test. Our observed is an A. Our expected is in V. I know B. I know we haven't put it there, but we're going to go ahead and act like we have. I'm going to press calculate. Now we're going to note these values because these are going to be important to us. 10.88, that's our chi-squared value. So the probability that we would get a chi-squared greater than 10.8838 would be a p-value of 0.0123 and our 0.0500. Well, while we're here, we might as well go ahead and make our decision. We know we're going to reject our null at this point because 123 is less than 500. So we're going to reject the hoe. All right. So let's go back. Oh, we also have our degrees of freedom, and so we can go ahead and write that down here. And please remember the degrees of freedom come from rows -1 times columns -1. And that's where we have 2 - 1 times 4 - 1, which is 3. So our degrees of freedom are 3. So we might as well note that down because that gives us that right there. All right. Now we're going to go back up into our matrix We're going to leave this and re-enter the matrix, but we're not going to A. We're going to drop down to letter B. And there we have our expected values. And we need to write all those down. So we have 56.91, 42.08. I don't have my glasses on. 36.21, and I'm only writing down 2 because I don't space decimal because I only have room for it. 23 is going to be 26.78, 17.24, 8.6. That's bigger than 5, so far so good. And then we have 6.3, and that's bigger than 5. As long as we're greater than or equal to 5 on our expected values, we're good to go. All right, so all of our expected values are greater than 5. So let's look at our conditions. Well, they told us we had a random sample of 207, and that was given, so we can check that off. 207 times 10 is 2070, which is less than the 2.8 million who have. That was our based on our population. We said at the very beginning, they said sample size of 207. They told us it was random sample, and they told us they had a population of 2.8. So we're good all on that. And we just calculated our expected values, and we see that they are greater than 5, and it should say see table above. All right. So we always need to show how we calculated it. Well, we only concern ourselves with the first one and the last one. Please remember, it's observed minus expected. So 46 minus 56.91 over the 56.91. Make sure that's squared. The observed of 3 minus the expected of 6.37, that's squared over the 6.37. And we know we had a 10.8838. Once again, our p-value was 0.0123. Take a look at that real quickly. All right, so there's once more looking at our, in case you were wondering where those expected values came from. Second quit, we rerun that test, stat test, chi-squared letter C. There's our chi-squared value, our p-value, and our degrees of freedom. Our decision was our p-value was less than alpha, so we reject. So our statement, our conclusion, the p-value is 0.0123. We reject the null. There is sufficient. We have plenty of evidence that alpha equal, and I don't remember what we suggested, 0.05, to suggest that the age group and gender are not independent in the diagnosis of schizophrenia. In other words, they are associated. All right. Or alternatively, you could say this. Oh, by the way, as always, and I always want to go back to this. Age group and gender are not independent in the diagnosis of schizophrenia. That was our Ha statement. Age group and gender are not independent in the diagnosis of schizophrenia. They're associated. Alternatively, we could say we reject the null. There is not sufficient evidence that alpha equal 0.05 to suggest that age group and gender are associated. That is also a Ha, which means they are not independent. Says the same thing. I prefer this one just because I feel like students tend to always get things right when they write it that way. Regardless, either one is accepted, and I'm sure glad you joined us. Hope to see you on the next one. Thank you.